Thanks everyone for joining. This is Running Dapper in Production with Confidence, Managing Dapper on Kubernetes with Diagrid Conductor. My name is Alice Gibbons, and I'm a Customer Success Engineer here at Diagrid. And we have a lot of exciting content to get through today. So I'll get going as a few more folks kind of trickle in here. And if you haven't, been to any of our webinars before, we have been doing a number of webinars here at Diagrid. And our mission is to boost developer productivity by providing tools and APIs for building and operating cloud-native applications. And these two fellows on the right here are our co-founders, Mark Fussell and Jeroen Schneider. They are the co-creators of the Dapper project, as well as the Gata open source projects when they were at Microsoft, and have been, Diagrid's been around for almost 2 years now. And so just kind of getting into what we're going to cover from an agenda perspective, I'm going to do a quick overview of Dapper and kind of take a view of it at 10,000 feet. Then we're going to dive right into some production challenges and demos. So typically the three demos that we're going to show are around operating Dapper, some of the security, performance, and reliability challenges and solutions there, as well as the insights and error detection challenges, and then get into some question and answer. If you have questions along the way, feel free to post them in the chat. I think that you can do that in the Zoom webinar question and answer box. And then at the end, hopefully will be a little bit of time to answer those. Cool. So I'm going to get going here. I wanted to start talking a little bit about some of the development concerns that developers have to face in today's environment, specifically around the growing requirements with multi-cloud and platforms, polyglotism, and really the popularity and rise of distributed applications. So there's a lot of words on the screen, but you can kind of think of some of these concerns in the 3 different categories broken down into networking, compute, and storage. And really, there are a ton of different networking options and protocols that would be good for different applications. Similarly, different languages that would be good for writing different types of applications. On the storage side, different data stores or different storage protocols that would be good for building different apps. And this has added an increased amount of complexity for developers that really has become an issue for building distributed apps again, as the popularity around multi-cloud, multi-platform, and distributed applications has grown in the past, I'd say 10 or so years here. And this kind of leads into some developer hypotheses that we wanted to cover. Specifically, developers are embracing this movement to build these loosely coupled application services that have become so popular running on platforms like Kubernetes. Developers typically want to focus on writing business logic instead of things like plumbing code, while they can lean on platforms to provide things like scale, resiliency, and maintainability. And kind of last but not least, developers are forced to solve these same distributed applications problems over and over, often re-implementing these same known patterns and practices, but maybe in different languages or maybe in different runtimes, because there isn't that portability across cloud and edge that just doesn't exist. So these are some of these hypotheses, and this kind of problem set is the reason why Dapper was created. And Dapr stands for the Distributed Application Runtime, if you haven't heard of it. And it was, as mentioned, it was co-created by our co-founders here at Diagrid and, released in 2019. And it, it was developed when they were on the Microsoft Incubations team in the Office of the CTO and made open source, donated to the Cloud Native Computing Foundation. And it's currently moving towards graduated status there. But you can kind of see, I actually stole this definition from a coworker, but we kind of like to define Dapper as a unified programming model that exposes application level APIs for building distributed apps using best practice software patterns and practices with complete code portability across cloud and edge. So you can kind of see my little fake Kubernetes cluster on the top here. And really Dapper is providing an abstraction in between the underlying infrastructure and your applications. And yeah, this is kind of the problem set that Dapper means to solve is like removing some of the complexity from developers while still enabling them to build applications really using microservices and distributed systems best practices. So what does that look like? Let's take a ample example of like a simple kind of distributed application. Not simple, there's 4 apps here. And maybe this architecture has apps that, are triggered based on and react to an event, maybe say being uploaded to S3. Maybe this application invokes another service asynchronously or, synchronously through request reply communication. In the same system, this could also interact with like third parties such as Twilio or like a Cassandra database. In this case, this might be running on AWS, but this could be really like any cloud or any platform that you would choose to run this distributed app on. Now, within this application, it's important to kind of take into account that all of these systems are depending on these external services and taking these SDKs, taking dependencies on these SDKs in order to reach out to the underlying infrastructure here. Now with Dapr, you can take the same application and remove these dependencies. So say if I have the same system, still service A is being like triggered by an event, and still, it's talking via asynchronously over publish and subscribe to, 2 other services. However, those dependencies that are directly on, AWS or whatever resources are removed from the code and actually, made simpler as you don't have nearly as many dependencies from within the code level, but then you also are adding observability, security, and resiliency features really across the entire application layer. So yeah, this provides a new level of portability and reliability at the app layer and gives the developers the flexibility to run these really on any platform without any code changes. And so that's kind of a look at what a Dapr application looks like. And this all uses what's called Dapper Components. Dapper Components are the infrastructure components that provide the connections to that underlying infrastructure. So, as mentioned, Dapr is an abstraction, and in order to fulfill the abstraction's needs, we have these things called Dapr Components. There are over 120 of them available, all open source and contributed by the community. And these are how, your applications, when running Dapr sidecars, are actually reaching out to that underlying infrastructure. The last thing I just wanted to touch on really quickly is that Dapr is backed by an ever-growing community. It is the 10th largest project within the Cloud Native Computing Foundation. As mentioned, it is moving towards graduation status as well this year, which is exciting. We have what we like to talk about is actually the contributor growth. So the graph on the bottom right is kind of looking at the contributor growth over time. And we are up to, over 7,000 GitHub or Discord members and over 3,000 code contributors as well. So really excited about kind of the community behind Dapr, as well as some of the contributing organizations who are helping make it success. So how does this all really look, right? You have your application, and as mentioned, this can be running in really any language or runtime. This is reaching out to whatever Dapr APIs you want to. Again, both over HTTP or gRPC, that's up to you. You can take advantage of one Dapr API or as many as you like. It's a bit of an opt-in model there, and you still get observability, security, and resiliency features with the APIs that you're taking like a dependency on there. And it can be hosted really on any cloud or edge infrastructure. However, what we do see, the reality is that over 90% of these Dapr workloads today are running on Kubernetes. And this is, there are ways to run Dapr on virtual machines. There are ways to run it elsewhere. However, this is just like the reality of kind of the cloud native space that we're running in. And this running on Kubernetes has become, has caused some issues in terms of running Dapr at scale. And so what we have done at Diagrid here, and this is kind of segueing into the next section, which is really just talking about some of the challenges that developers have and operations teams when they're running Dapr on Kubernetes specifically. So first one I want to talk about is Dapr upgrades. Oftentimes, upgrading Dapr is a manual process, and you have to coordinate both the application rollouts along with the control plane. So Dapr has what's called a control plane that it depends on. Actually, if I do the next slide, you can kind of see a little picture of the control plane down here. There are 4 main pieces of that control plane, and this is something that needs to be kept up in order for all of your applications that have Dapr sidecars to work correctly. And oftentimes these control planes might have inconsistent control plane configuration and have environmental discrepancies that might not be caught by cluster admins. Specifically, another thing that's a common trip up with running Dapr in production is root certificate expirations that cause production downtime. So one of the features Dapr has is enabling mTLS encryption between your applications, but then also between Dapr sidecars and the Dapr control plane. And in Dapr open source, these root certificates are self-signed and expire after a year. So if you don't have a process that rotates those automatically, we often have users experiencing downtime based on those certificates expiring. Last but not least, Dapr is a very fast-moving open source project. There are releases that come out around 4 times a year, but then hot fixes can come out weekly or even more quick depending on the security patch. And remaining within version support of that is very difficult. We've had many users tell us that. You can, of course, use Helm for things like this, or the Dapr CLI, but this is still a point of contention with users. And then, also automation is also not limited. You're limited to Helm there. So whatever you want to do from a GitOps or CI/CD DevOps pipeline perspective, you are limited to kind of what's provided with Helm. So with Conductor, we have the Diagrid Conductor agent. And this is an agent that you install on your cluster. And this can be really any Kubernetes cluster. And this is running and reporting back metrics as well as data to our cloud in Diagrid Cloud here. And we get automatic 0 downtime upgrades and rollbacks. So you can actually schedule the control plane upgrades on select Dapr sidecars in order to get specific upgrades for your Dapr control plane. From a cluster standardization perspective, as mentioned, Conductor supports all different Dapr or Kubernetes distributions. So maybe you have some running on premises, maybe you are multi-cloud, maybe you want to just enable your local development environments with Conductor. Those are all options for you. And we also provide default development and production settings that have top concerns like high availability enabled or using the Dapr watchdog. From a certificate management perspective, Conductor also provides worry-free kind of Dapr certificate management. This will rotate the Dapr root certificates automatically, and you can choose the specified frequency and renewal window at which those are rotated. And last but not least, you can easily check out these new Dapr versions using Conductor. So we load new Dapr versions into Conductor within 24 hours, including release candidate versions, and you can kind of see these in testing them out in your cluster live with the newest version that's out there. And then, also, I guess, last but not least, we do have a GitOps operator that you can, we have a Kubernetes operator that you can use with your GitOps workflows, or we also have a Diagrid CLI that we have many users using within their DevOps pipelines. It's kind of giving you a few more options around automation there. With that, I'm going to jump into a quick demo. The first one, just kind of showing what this looks like from an installation, upgrades, and rollbacks perspective using Conductor. So if I jump, I think that's just still working. So you can see on my screen here, I'm actually within the Conductor Dashboard. And this is kind of your one-stop shop for all of the Dapr clusters that you want to onboard into Conductor. You can see, the ones running locally on your machine, as well as any different Kubernetes clusters that are running across cloud. I can see, some of the most important statuses, things like if that control plane is up and running, whether that agent, this is the Conductor agent, is healthy, the version running, number of applications, things like that. And connecting a new cluster is super easy. And it takes just maybe around 30 seconds. I'm going to create one here running on and this is just a local cluster that I have on my local machine. But Conductor supports many different or all different Kubernetes distributions. Specifically, we test on all the three main cloud providers as well as OpenShift, but we do also support local distributions like Kind, Minikube, and Docker Desktop. The other option to choose here is just whether you want a production or non-production cluster type. And this is very specific to, if you have a Diagrid plan or a plan with us, you can actually get Dapr open source enterprise support for your production clusters. So if, support using the GitHub and open source support methods like Discord are not sufficient, for your organization, one of the things you can do is we offer support contracts with SLAs as low as 1 hour. You can also install the Dapper control plane. So this is kind of a one-click Dapper control plane installation, or you can also upgrade the control plane that is if it already exists on your cluster. I'm going to choose my version here. You can see we have a number of versions. This is within the open source version support policy of the current version and the previous two minor versions. I'm going to choose 12.5, it's the newest version, but you can see that we also have some release candidate versions already loaded in here. If I wanted to test out, the newest version of 113, that's an option for me. And then we provide some dev and production sample Helm values. These are going to be specific to, whatever environment you're running. We're going to give you some default values here, things like with best practices enabled. So, things like mTLS enabled, the watch interval for the Dapper watchdog, which is actually a really important feature, excuse me, that will ensure that if any of your nodes go down, and then your applications get spun up before the Dapper control plane, that the sidecar will still get injected due to checking at a 3-minute interval. The other thing that we're going to look at on cluster installation is this certificate rotation. So, as mentioned, these Dapper open source root certificates will expire after 1 year, and they are self-signed. What we do at Diagrid is we replace them with Diagrid signed certificates, and then you can provide a renewal frequency as well as a renewal window, and we will rotate those certificates automatically for you. And this, again, that's a huge production mishap that has caused many users downtime in production. So I'm going to create this, and again, I'm just creating this within the UI, but as mentioned, we do have a cluster operator as well as the Diagrid CLI where you can use to create these cluster connections as well. So switching over to my terminal, again, I'm just running a local Kind cluster on my machine, nothing too crazy here, but I can copy that kubectl command that I got from the Conductor Dashboard, and I'm going to paste this into my cluster. And again, if I'm playing the role of a cluster admin, I can kind of see this kind of getting installed. So the two main things you want to look at that are getting installed are a deployment and a daemon set from Diagrid, and these are the ones that are going to connect your cluster to our cloud. Click done there, and you can see now I have a new version of Kind running within, or I have a new cluster in my dashboard here. And so this is going to do an upgrade because I did already have a version of Dapper installed in there. But if I jump into the cluster itself, I can already see a number of insights kind of right off the bat. So for instance, I can see the cluster kind of all up, and some of the things that are most important to me, maybe as a cluster administrator, things like the control plane, right? So this is going to look at the Dapper control plane in particular. I just did that installation onto a version Dapper 1.12.5, and so this is actually doing an install right now, hence why it says degraded. I can take a peek into the 4 main pieces of the control plane here, and that's going to be the injector, the operator, the placement service, and the sentry service. And then I can also look at some of the CPU and memory over the past 5 minutes. So these are just loading, but you can kind of see, I can get a peek into what those are actually using, and then if there's any spikiness or something that doesn't seem normal there. Also, Conductor provides default alerts for the control plane. So if any of these pieces go down for more than 2 minutes, you also are going to get alerted on that kind of by default. The other thing you can kind of see in this cluster dashboard here is the versions. So, I have my Dapr version, the one that I just deployed, which is 1.12.5. And then if I look at some additional cluster details on the right-hand side here, I can also see that there is this upgrade available. So, one of the things that you can do within Conductor is like one-click easy upgrades. So I know I just installed 1.12.5, but I'm going to do another upgrade because I can. And I'm going to upgrade to this release candidate version. What we offer from an upgrade perspective in Conductor is you can choose the newest version to upgrade to, obviously, and we support, you can only roll back, or you can only go down by a minor version or up by a minor version. So that's why, these previous versions are grayed out on the platform, because that is what's tested by the open source project. And then we can choose the version we want to upgrade to, and then choose which applications we want to roll out. And this is really important, right? Because this specifically is going to upgrade the Dapper control plane to that newest version, but then only upgrade a select amount of sidecars if that control plane upgrade is successful. So what I mean by that is, if I want to roll out all apps, I totally can, or I can just choose a subset of my Dapper enabled applications, and then these apps will get the newest version of the sidecar only. Kind of like a little bit like a blue-green deployment there. It's going to pull all the Helm arguments from my cluster. Of course, this is all editable, so if I need to make any changes on my upgrade, totally can. And then I can also schedule this upgrade to, maybe be at a time when, my business won't be as affected, something like that. I'm going to do this right now, so I'm not just schedule it, but a handy feature if you have low usage times, because you do still have to roll out your applications. It's just done for you by Conductor. So yeah, that's going to do a rollout. I'm going to see that everything kind of happening within the UI here. I have this version processing, and then it's going to change to upgrading slowly. I can also, head back to that control plane view and then view this kind of being taken down and then picked back up, like individually by each pod. And then the other really nice thing that Conductor provides you here is not only will so it's going to do the control plane upgrade first. If that fails, it's actually going to roll back to the previous version that was successful. So, I'm upgrading to 113. There's a bunch of changes in 113. Maybe something's going on, something happens with the control plane. That's going to go get automatically reverted by Conductor if anything fails back to that 112.5. If that fails. So yeah, you can see that this guy looks good. So now it's on 113. If I head now into my applications, if you remember, I only chose a single one of those applications to roll out. And now you can see I only have one of those apps has the newest Dapper version and the other one doesn't. So yeah, just a number of ways you can kind of control your upgrade using Conductor. The last thing I just wanted to touch on was the revert Dapper settings option. And so what we also have is, say something goes super wrong and you're like, hey, you know what, my application is failing with 113 and I just want to go back to what I know was working. I have the option to kind of revert everything back here, and you can kind of see the previous version that was deployed as well as those previous Helm values and like directly pulled from the control plane. So with that was kind of an overview in terms of how to get started on Conductor, as well as, doing a cluster onboard as well as an upgrade. Switching back to slides now. I wanted to jump into some of the security, reliability, and performance settings. So these are some of the challenges that we have seen people face around security, performance, and reliability, specifically when they're running Dapr in production. The first one I want to touch on here was just like the resourcing of the applications and their sidecars. So, sidecar pattern is a very popular pattern in Kubernetes. Many, service meshes run as the sidecar. Many other Kubernetes deployments run as the sidecar. However, you can over provision both the applications and the sidecars and have like overall low resource usage. Also, some security recommendations are not necessarily followed. So we see many users that have, Dapper components, which again are those infrastructure manifests without maybe application scopes or plain text secrets and files. And, a lot of people don't know that that's actually not a best practice for production workloads. Similarly, my slides will work. Then some of the other things that we find is that some of these best practices that we're discussing on this call are really buried in a lot of documentation. So reading through pages of docs to kind of discover these new Dapper best practices for each version that comes out. Whereas, and then also the Dapper component validation. So this is another thing. So I have on the right here, this is just a sample component manifest file, and this is going to be what connecting in this case to a Kafka broker, let's say. And this Kafka broker is actually storing a secret in plain text here. So that's one good thing. But say, my secret accidentally gets, changed or something happens and I cannot connect to that broker anymore. That's something that is only actually a Dapper runtime area that you see. And so some of these are issues that, we have found that actually have given users production downtime. And so using Conductor, how does this look any different? Well, we do provide automatic Kubernetes resource recommendations. These are specific to your application as well as your sidecar resource optimizations. And, we have found actually led to significant cost savings on CPU and memory. So we've had, customers actually tell us that they've been able to reduce their cloud spend and actually save the money at the end of the day, which is huge. Also, some of the security best practices, some of the ones that I mentioned, so like storing your secrets directly within your component files, as well as what we call scoping in Dapper. So specifically, that is ensuring that only some components have access to, or only some applications have access to some components, right? So only essentially the applications here, 1 and 2, will load the component for will load this specific state store component, in this case, the Redis state store. We also, of course, recommend using secrets. So using a secret instead of storing your component within the manifest directly. And so, yes, using Conductor, those things are called out, as well as we have what's called the Conductor Advisor. And this is super critical because it provides you security, reliability, performance, and observability advisories. And you can kind of see a little sneak peek on the top here. They're all different, really, levels or impact levels. And this is completely catered or specific to your applications. So, you install the Conductor agent on your cluster, and then these get automatically generated based on your system. And then we also have the component errors that are found within development environments. And this is a huge thing from an initialization perspective. So Dapper components, some of these initialization errors, like the one I was talking about with like a wrong secret or maybe a network firewall rule that has somehow changed. And now your application cannot reach out to the underlying infrastructure anymore. We have this initialization status, which will actually show you that right within Conductor. So what does that look like? Again, I'm going to flip over to the Conductor portal and just show you. So I'm going to head back into a different cluster at this point, just because this one has a few more applications. In this case, I'm going to go back into the cluster dashboard to kind of start looking at some of these security, reliability, and performance best practices. One of the first one I'm going to notice is on my cluster level, I have what's called these high impact advisories. So this is kind of bringing up some of the most important advisories that I need to care about, again, as a cluster admin for this Kubernetes cluster. In this case, this is telling me that my control plane is not deployed with a highly available configuration. This just means that the control plane, the components that I installed at the beginning, those are only deployed like maybe with one replica and should be deployed with more than one replica from a reliability perspective. We offer the ability to either dismiss or fix these advisories. Excuse me, and if you fix these advisories, what this is going to do is it's going to apply the fix to your control plane and then automatically roll out the control plane resources to ensure that these are deployed with high availability in this case. So I can look at all of these advisories if I jump and click on the see all. So you can kind of see I have them broken in across categories. Jumping into that security one, some of the recommendations I get from a security perspective, this first one here is going to tell me, hey, this component contains sensitive information as plain text. So again, this is like the Kafka example I showed, but like we have the option to either store those secrets directly within your manifest files. And that is definitely not a best practice in case there is like a bad actor or something that gets in your cluster boundary, network boundary. And so what we recommend doing is using what's called the Dapr secrets store to reach out to a secret store wherever that might be. Maybe that is in Kubernetes, maybe it's in, AWS Secret Manager, and then replace that direct value with a secret key reference. And this also is going to tell me the specific impacted resource. It's going to give me a link to docs for how to fix it. And then I also have the option to dismiss these. So, maybe this is my development environment and I actually know that, this secret is in this file and I don't care about it. That's an option for me as well. So I can also, take a peek at just the actual impacted resource itself. And this is going to give me an even more kind of detailed view into Dapper components. And so in Conductor, you can actually see all of the different components that are deployed on your cluster. So you can see I have this Kafka component, and this is, showing up because I have that password actually stored in plain text here. Something else I just wanted to call out is that Conductor actually obfuscates the secrets from within the agent. So, your secret data is never actually leaving your cluster. It actually is just staying within, your cluster boundary itself. But these advisories are still getting run and kind of delivering you these insights within our cloud. Also, while we're on the kind of components page, this is going to show you all of the different components across the cluster. So this is going to show me all of my different infrastructure resources that are running, and I can see a number of different details about them. Things like, the state store, I have an error on my initialization status. So what does that mean? In this case, my initialization status is going to check to make sure that I can access that underlying resource, right? So this is, again, a common error that people see, they notice when it's like during runtime. And this will actually fail to reach out often in terms of, your code reaching out to this, in this case, the Redis state store. I can also get a bit deeper view into what's actually happening and why this actual initialization error is failing. Because, typically this would actually just show up within the Dapper sidecar logs, but now I can see it, directly within the UI here. The other thing that is important to note in the components section is just that you can see all of the scoped applications. So, I have, a number of applications and they're all different. They're scoped to number of components and they're all scoped to different applications. In this case, we have these scopes are super critical because they ensure that, only certain applications can access certain infrastructure resources. And again, you want to follow like principal least privilege here to ensure that, you have only specific apps talking to that right infrastructure. Heading back to an advisor perspective, we also do get a notification, essentially, if a component has no scopes defined. And then another critical Dapper kind of key point here is that if you don't have any scopes, all of your applications can actually access your component, right? Which not only is a bit of a security risk, but you can also have some undefined behavior within your application. So if something like a input binding is not scoped to anything, you're actually going to get the input binding calling out to all of your different apps on an endpoint or on a route that isn't necessarily implemented by your app, providing like potentially bugs or errors. We also have some reliability recommendations. We see that one around, the control plane not being deployed with highly available. We also have one here telling me that I have detected high cardinality metrics. And this is super important because this is a feature that just came out, I think in 1.11, a couple releases ago. But essentially, we are able to detect in Conductor here that you have a huge amount of metrics coming in from one specific app, and this can cause performance issues either with your monitoring system or really like anything that's downstream of anything that's picking up those metrics and traces. This is going to tell me specifically what application is impacted by this, as well as what metrics I can actually use. I can actually add a regular expression here within Dapper in order to fix that. From a performance perspective, we have a number of advisories here, and this is actually where we're going to look at some of those to improve some of those performance of those applications and their sidecars. So, if I click on this first one, this is telling me, hey, this application, in this case, it's called the accounting service. It's telling me that these resource settings can be optimized. So essentially, what we do in Conductor is we look at the top 10 most resource intensive applications running within your cluster, and we're going to give you requests for how those should potentially be changed based on the usage pattern over the past 10 to 15 days. So, for instance, in this case, the accounting service, we're going to look at both the Dapr sidecar usage as well as the application usage, application container usage, and double check to see if there are any requests or memory limits set today. And then give you some values for what you should set those for. So in this case, it's telling me, hey, the Dapr sidecar this is what the average usage is over the past 15 days on 4 millicores and 31 megabytes. And based on that, we're going to use a 10% resource buffer to give you some recommended usage settings. And these have to be applied within the pod spec as Dapr annotations. And it's going to tell me, give me a few of these, including this new one that we added, which is specific to the Go runtime. It will actually allow the sidecar garbage collector to start garbage collecting some memory when it reaches 90% of the memory limit. So again, kind of reducing the amount of out of memory killed errors that you'll actually receive within your cluster. That's also going to happen for the application container. So in this case, we're like looking at that usage over the past 10 to 15 days, giving you new requests and limits. And again, this is just something, of course, you have to have approximate usage within your app in order for these to be useful for you at all. But it is still, we have found, again, customers have really liked this and they've seen, up to 80% actually memory reductions and CPU reductions in terms of their cloud spend for some apps, which is great. That's mostly what I want to show from a advisory perspective. I'm going to jump over into one more set of slides, kind of talking about issue debugging. So this is the demo slide. After, one of the other main issues that we have found, within running Dapr is just really like insights and overall error detection. You are taking a dependency on another, more application. Your applications are taking dependency on another system, another process, that being Dapr. And we have found that, this lack of visibility across teams and really, the Dapr dependencies causes like disparate service teams, maybe that are working on different applications to have a really lack of visibility into kind of how that end-to-end system works. So, because Dapr is that API between your applications and your infrastructure, it provides, again, that level of abstraction, which is great, but it does actually kind of cross the platform team as well as like the developer teams in terms of like the stakeholders. And this also causes time-consuming troubleshooting between platform and dev teams. You have like cluster admins that are forced to like really, really, really get in the weeds with Dapr, which at the end of the day is like a developer tool. And this, of course, you can build out monitoring dashboards for this. These can be time consuming to build out, and you have to scrape all of the Prometheus metrics endpoints on each sidecar, as well as make sense of, some of that control plane data. We have people using OpenTelemetry for this, the OpenTelemetry collector, but there are, over 150 metrics that Dapr provides you out of the box, and some of these alerts are specific. You have to decide which ones, you actually want to alert on and which ones are important, kind of separating that signal from the noise. Last but not least, the other feedback we constantly get for running in production is really just around visibility into Dapr actors. So if you if you're using the Dapr actor API or the Dapr actor model, it is a very powerful system, but you have to it's very hard to visualize effectively what's going on within your cluster in terms of what actor types are running, where are they running, how many instances of the placement table are running behind the scenes, things like that. And this really, forces, again, the kind of the working together of dev teams and platform teams, and really cluster admins, forced to get deep into what's actually happening within the application, causing slower resolution times. So what does that look like within Conductor? I feel like know where I'm going now with this. But essentially what we provide in Conductor is a dynamic application graph. This is going to dynamically build a dependency graph of all your different apps, right? So you can kind of see on the right here, you have, your applications, they maybe are talking to each other. They're also talking to, those underlying dependencies. And this is going to generate an automatic topology for the apps and infra without really embedding any tracing SDKs. We're just using metrics, the Dapper metrics, to actually generate this graph. We've found that this has led to a reduced time to Dapper issue discovery and resolution. Again, there's just a single source of truth for this Dapper troubleshooting. You have this shared understanding between your platform and your DevOps and your developer teams with Conductor. We also do provide pre-built Dapper monitoring dashboards, of course. So, each application has around 18 different pre-built Dapper dashboards for both, and I'll show what some of these look like for both the HTTP and gRPC calls that you might be using within those APIs. And last but not least, we have default and custom alert capabilities. So, instead of having to kind of figure out which applications should I create alerts on, and what applications, should I kind of or what metrics, what metrics should I create alerts on, and what metrics are not as important to me, Conductor will do some of that for you. So you can use the default ones that are created out of box, or you can kind of take advantage of the custom metrics, and create your own. And then last but not least, we do have some insights into actor usage. So again, providing some default graphs there as well. And you can kind of actually see the breakdown of where those actors actually are in terms of what nodes, what pods they're actually in, and allows you to kind of troubleshoot any actor issues that you might face. And then, you can kind of see this little photo on the right here. It's giving you an idea of hey, this is the Conductor agent reporting back to, Diagrid Cloud, and it reports things like application alerts, control plane alerts, and component specific alerts. In this case, it's just showing a Kafka example. So in the last demo, I want to show how to detect and resolve a Dapper issue in Conductor. And so to do this, actually going to flip back over to my terminal here. And so I'm just going to switch clusters. And okay, so I am now running within a GKE cluster in this case. It's not important, but I'm running within a GKE cluster. I have a number of what are called Dapper components running here, okay? And this is going to help me. These are, this is how I connect from my applications to my underlying infrastructure. And so what I also am going to do is I'm just going to show you what this one looks like. And just to prove, there you go, that this one is running successfully, and it's all working in my cluster here. So this is, in this case, the order make line service, and this is a Redis cluster, and I'm going to delete this. So I'm going to delete my component that this entirely, so that my application will generate a bunch of errors, and I'm just going to show you what that looks like within Conductor. So let's delete this. So I'm deleting this guy, that's great. And just to prove that the component is deleted, I'm gonna hop over to, on the top here, I have my logs. In this case, this is my order management system. This is my make line service. These are the actual application logs. And you can see, oh, they already got in there. If I scroll up a little bit, you can see that these are completing successfully right now. Right here. These are completed successfully right now from there on. So I have, I'm getting completed. These all look good. I'm running HTTP deletes in this case, but so far so good. And actually, because I'm running a new feature or the newest version of Dapper, the 1.13 release candidate in this cluster, what's actually able to happen, so on the bottom part here is my sidecar logs, is I actually will see this deleted component automatically showing up here. So the one that I just deleted is this one, is the receipt. But essentially what is going to happen is, because I deleted that make line state, I'm going to see this component get entirely deleted within my Dapper sidecar, and then it's already spewing errors from my application logs on the top. So that's what's happening in terms of a cluster perspective. If I flip over now to Conductor, so this is this cluster, the one that I'm in. I'm going to take a look at what this looks like. So again, I'm going to start at my cluster dashboard. And this again is going to be that insights across clusters, applications, and components. So I'm going to take a peek at some of the components here. From an app insights perspective, we have a number of things that we show in the components dashboard. Specifically, we're going to show any fatal logs issues that have happened in the past hour. We're going to show any critical metrics, and these are going to be specific to some of the default alerts that are created. And then we're going to show some high impact advisories that are, again, affecting at the application level. And all of these different metrics are actually driven by these metrics rules. And so, as mentioned, Conductor comes with a number of default rules out of the box. These are specific to, you can see all these ones that are prefixed with default here. There's 15 that come out of the box, and they are all different, app to Dapper HTTP error rate, or, gRPC error rate. We also have, so this is like going to be, all your calls from the Dapper sidecar into your application, or all the calls from your application out to your Dapper sidecar in whatever protocol. We also have things like the app component error rate, and this is going to be any calls like out into your component or in from your component, and if those are failing. We also have these default alerts for the control plane. So, these are the 4 main pieces of the control plane. And if they are down for more than 2 minutes, you're actually going to see an alert on all of those. You can also create your own, right? So say if I wanted to come in here and create my own alert, I'm going to jump, I'm going to create a metrics alert. I have the option of, the 3 kind of levels: cluster, application, component. I'm going to choose application at this point. And then, I have a number of different options here. So, I can get as granular as I want to in terms of, the latency, RPS, and error rate for both app to Dapper, again, reaching out to the Dapper sidecar, or Dapper to app calls. And you can also see there's a few other metrics in here, things like memory, CPU, kind of basic Kubernetes triggers that you might want to alert on. Yeah, like crash like that off, for instance. So, but yeah, you can specify if you want to alert specifically on the Dapper sidecar in this case. So those are kind of how the default alerts are working, and that's kind of what's powering that dashboard. Other thing I wanted to talk about quickly was just the channels. So, this is how you can integrate with any other alerting systems or monitoring systems. And so today, we are piping all of these alerts and these metrics into Conductor, but, maybe you are using a different Azure monitor, maybe for your monitoring system, and maybe you're using something else. There's a million different monitoring tools out there. And so what you can do is you can actually have either an email or a webhook that will actually take some of these alerts and pipe them into kind of whatever system that you wanted to. We have people using different alerting systems, or we also have them running it to like an Azure function or something that would like push it right into Slack or something else like that. From a integration perspective, the other thing I want to call out is we also have a default Grafana dashboard. And this is a feature that, if you are a Grafana user or a Prometheus user, and you really like, you also are a Dapper user and you like the idea of having some of the features of Conductor, but maybe you live day and night within your Grafana dashboards, what you can do is you can download the default Grafana dashboard template. I'm going to flip over to that right now. And you can see by looking at this dashboard, it looks very similar to a lot of the insights you're going to get in Conductor. However, living in your native kind of monitoring tool. So all of these also, I should mention, link back to the specific conductor graph that is necessary to kind of get more details on some of these alerts. So for instance, this is the high impact advisories. This is going to link me back to my advisories that are, firing in this space for this specific cluster. And similarly with, some of the application metrics. So I can see, a number of the application metrics for specific application IDs or specific clusters as well within this dashboard. So heading back to Conductor now, if I go, so that was this, I wanted to, so I now, if you remember, I deleted that. I deleted my state store. What happened? The other thing I just wanted to show you was, so some of these alerts are already firing. So you can see now in the past, let's change these to metrics. Hour. You can see now in the past like 1 hour, I have a huge number of alerts that have gone off, right? So these are all kind of firing specifically for my applications that something's going on here, right? So maybe I want to take a deeper look into this application. So I click on this one. It's telling me, hey, this is the make line service. This has been the app to Dapr gRPC error rate in this case has been more than 30% for, in this case, 2 minutes. This allows me to kind of jump into the specific app. It's going to tell me some of these critical metrics issues that are firing for this app at the app level as well. I can also see, a number of other things here, things like the Dapper annotations this was deployed with. But, if I jump kind of back into those notifications, I can kind of get a deeper look into what metric is actually driving this, right? Which is like going to help me lead me to a resolution. So if I click on the source metric, it's going to show me this application graph that is going to tell me, hey, this is what's actually failing. So this makes sense because, I deleted my state store in this case, and this is my gRPC request error rate. And this has, gone up hugely in the past. I believe this is my 5-minute interval, right? Yeah, 5-minute interval. So this is, going to show me in the past 5 minutes, this getting state is now up to 100% in terms of that error rate. So that's like one way to kind of figure out, hey, this is something is going on in Conductor. The other way to kind of figure that out is if I head back to my applications, oops, I meant to click on applications, I can also see this at a glance. So, these are all of my different apps that are running within Conductor. Makeline service was, again, the one I just deleted that state store for. You can see it's showing a big red X, so some issues were detected there. But I can also view this as a graphical view. So here's what we have, the applications graph. And this is going to show me kind of this is that topology graph that's going to show me like how all my different applications are connected. And I have these solid lines, which are the service-to-service invocation calls or Dapper service invocation, but then we also have these dotted lines that are representing pub/sub or message broker communication. You can also isolate on specific apps on this point, and so I can see, hey, I have a number of services that are actually publishing. In this case, this is on a Kafka message broker, and then there is a number of subscribing applications on the subscribing side as well. So each of these, when you isolate on an app, you can actually view the near real-time error rate, RPS, and latency of that app, of that app call. And you can also view, just kind of right off the bat here, you can see this one is turning orange because this has a high latency essentially on this specific application. So if I isolate now on this message broker, I can see not only how my applications are connected, but I can also view these error rates that are coming up specifically on my apps, right? So I can see, hey, this one has a 100% error rate, reaching out in this case to that state store. And then, from this page, I also can kind of jump into that application specific view, right? So the application specific view that I was looking at before, but I can also, access from my applications graph. But yeah, this is kind of what allows you to drill down into these specific apps and then view this, or view your application issues as they might be coming up in an unsuspected way. But I'm realizing now we only have 4 minutes left, so we went a little bit over time. But if I wanted to just check now for some of the questions. But yeah, so that was just kind of an overview of Diagrid Conductor and how it kind of will help you in terms of the production best practices. One of the things that we just announced actually on Tuesday is a self-service free trial. So if you head to diagrid.io/conductor, you can get a free trial of essentially everything I demonstrated today. And we also do provide Dapr open source enterprise support here at Diagrid. So if that's something that either you or one of your Dapr users is requests, then that is something that we can provide. We also do have a Discord community where we answer some questions if you have any additional questions.